Good evening. In our previous videos we soldered an ESP8266 microcontroller, a crystal oscillator and a Wi-Fi antenna directly to this green adapter plate. Our do-it-yourself module is now quite stable. Our next concern will be these jumper wire connections that we have on our breadboard. For instance, if any one of these 17 points should have even a slightly loose connection, the pin number 1 and consequently the whole ESP8266 chip wouldn't function properly. That's why I have soldered on this PCB board exactly the same components and exactly the same connections as we made on a breadboard in our first video. Today we anyhow shall still stick to our breadboard connection for a while because we want to test the notorious GPIO9 and GPIO10 pins. The ESP8266EX hardware user guide is already familiar to us. There is a figure on the page 38 that tells that for a flash memory chip one can also use a so-called dual SPI mode. This means that we are free to use for our own purposes those ESP8266 pins number 18 and 19 that up till now have been connected to the flash memory chips pins number 3 and 7. The flash memory chip doesn't mind if we just pull up it's those two pins that we now want to leave unused. And we need to tell the Arduino IDE that this time we won't use the previous so-called quad SPI mode, but instead the dual SPI mode. Let's choose the famous Arduino IDE example program that blinks on and off the input-output signal line number 13. Let's test it with a LED at our GPIO13 pin. And let's get rid of these black jumper wires and replace them with a pair of buttons that, when pressed, connect to the ground the flash pin number 15 and respectively the reset pin number 32. This 470 picofarad capacitor smoothens the noise that usually comes from a button pressing. And this 470 ohm resistor protects the pin number 15 from a shortcut that would occur if we should push the grounding button at the same time when the pin itself is outputting a logic high. We use these buttons in the same order as we earlier did with the black jumper wires. We click this Arduino IDE upload arrow and we see that we indeed are able to upload and run programs without using the GPIO9 and GPIO10 pins. As a matter of fact, for uploading we don't have to push any buttons at all if we only make use of these signals RTS, ready to send, and DTR, data terminal ready. Circuit diagram of the famous Node MCU version 0.9 shows the simple connections that are needed. You can find these necessary few components from every store that sells electronic components. Now choose Arduino IDE tools and change the reset method from our previous CK reset method to our new Node MCU reset method. As we now want to blink the GPIO9 pin, we need a program for that purpose. And we see that with the help of our two transistors we can now upload new programs to our ESP modules just as easily as we are used to do with Arduino Unos, for example. And we see that our new program works as well, and we indeed can use the GPIO 9 pin for our own purposes. Let's also try those other connections that lie between the USB cable of the Node MCU 0.9 and its ESP module. You can take the CH340G chip and other necessary components from this cheap USB to serial converter. To test the new connections, let's again do a small change to the blink program so that this time it tries to blink a LED at GPIO 10 pin. And we see that our new program and our new connections work as well. And what we have here, this 32 here means megabits and it is equal to 4 megabytes. This is the biggest flash memory size that an ESP8266 microcontroller's bootloader can have. Let's connect it to our breadboard, inform the Arduino IDE of the new flash memory size, make some changes to the blink program and look again at our breadboard. And we see that our system works very fine with a big-sized memory as well. If we now compare the Node MCU 0.9 development kit and our ESP do-it-yourself with its new breadboard, we see that the only advantage in Node MCU is that it uses an ESP12 module that has been approved by the American and European authorities. But in the next video also we are going to make an ESP do-it-yourself module that is approved by the American and European authorities. So stay tuned if you are interested in that kind of modules. Goodbye.